see what we can do. So 1.1 notes, key features of functions. Excuse me. Based on the graph, what is the lower and upper bound on data? So we're talking about the gigabytes there. Well, what's the lowest x value that we have? Well, it's at 0. And then, well, this keeps going on forever. It doesn't have an upper bound on the x values. So we'll say infinity. Based on the graph, what is the lower and upper bound on cost? Cost, it looks like the lowest y value, the lowest cost, is 4. There's nothing lower than 4. And then again, it goes up and up and up forever. It never stops. They'll charge as much as they can. So it's infinity again. Then we have, what does a y-intercept represent? Well, first of all, what is a y-intercept? 0, 4, right here. So what that means is if we use 0 gigabytes of data, we will pay $4. So obviously that doesn't really make a lot of sense because if you're getting nothing, you shouldn't pay money. But they're saying that's kind of the start. The lowest that they can pay is $4. And then it goes up from there. Write an equation for the cost. Well, if we kick it old school, remember y equals mx plus b. M is our slope. Rise over run. And b is our y-intercept. So we already have our y-intercept. So c of x, and again, c is just the name. X is our variable. We don't know the slope yet. We'll find it in a second. But the y-intercept is 4. So just plus 4 at the end. That's our b. To find our slope, we got to look at our graph because we don't have the actual equation. We're making the equation. So from this point, to another full point, maybe here, we rise 2, we run 4. So rise, again, 2 over 4, simplifies down to 1/2, and that is our slope. So our equation is 1/2 x plus 4. And that's all we need to look at there. Now letter E, find C6. So what we're saying here and what's going on there is, and that's C of x. We can do one of two things. We can plug in 6 for x into the equation. So 1/2 of 6 plus 4, that's 3 plus 4, so $7. Or that's our x. We just go x equals 6. We go up to our graph, and then we go over to where our y value is, and that set of coordinates is 6, 7, and that's what we found. Now f is the same thing, except we're going backwards. Now if someone paid $8, how many gigabytes did they use? So we start at 8 on our y, and we go over till we get to our function, our line, and we go down, and they used 8 gigabytes because this ordered pair is 8, 8. So same idea, same thing there. So we talked about domain and range. Domain is all the possible inputs or the x values. Range is all the outputs or y values. Interval notation just says where we start and stop something. Set builder notation is with our inequalities. So all numbers between 3 and 7. So we can think of these as number lines. Whoop. Don't know what happened there. So 3, 4, 5, 6, and 7. It doesn't say including them. So open circle, and then we shade in the middle. Knew that was going to happen. So set builder notation, we got a squiggly bracket. We say what our variable is going to be, x or any other variable. A line saying, well, we're separating the variable from what our rule is. And our rule is that 3 is less than x, less than 7. We're just putting it in inequality form, and x is between 3 and 7, and it's not equal to 3 or 7. They're not shaded in circles, so we can't do anything with that. Now, if we're talking about our number lines again, so open circles would be less than or greater than. A shaded in circle would be less than or equal to, and greater than or equal to. Well, with interval notation, we're either using square brackets or parentheses. If it's an open circle, we use parentheses. If it's a filled in circle, or it's less than or equal to or greater than or equal to, we use square brackets. So interval notation. So all we're saying is that we're starting at 3, comma, we're going to 7, and those numbers are not included, they're open circles, so we have parentheses. So that's it for interval notation. It's a lot less work, and that's kind of the good part. All numbers greater or equal to 3 and less than 7. So the only difference, I'm going to use a different variable because why not, is that it can be less or greater than or equal to 3 as well this time. 7 still can't be 7. So it means it goes from 3 to 7, not including 7, but now including 3, so we have a square bracket. All numbers less than 5. Well, again, we need our variable c, and c is just less than 5. That's literally what it's saying. All numbers less than 5, well, c is that number, and c is less than 5. So this gets a little bit more involved here. So we're talking 5, 6, 7. It's an open circle, and it's everything that way to the left. So where does it start? Well, we can't see where it starts because it's going left for forever, so it's over there somewhere. So it really starts at negative infinity because it's way down there. It's going left for forever. Where does it stop? Well, it stops at 5. Is 5 part of our answer? Is it in a closed circle? No, so we have parentheses. And our infinities will always be parentheses. And then all real numbers, of course, a number line, kind of it's just everything. So we can put all real numbers. We need the all, or else it's not saying what we want it to say. Or, well, it starts at negative infinity, so all the way to the left, and it goes all the way to the right, so it's positive infinity, and then they're both parentheses. So that's our interval notation and our set builder notation. We're going to focus mainly on interval notation. So find the domain and range of the following graphs in interval and set builder notation. We'll keep this color for a bit. So letter A. If we're looking at x values, it's just from here to here. It's just a number line. So set builder notation, this is domain, is x, and we have to use x, so we're talking about x values, such that, well, negative 5 less than or equal to x less than or equal to 4. And it's less than or equal to's because they're shaded in. Now, if we were to write it in interval notation, it's from negative 5 to 4, including them. So that's it. Much quicker, much easier. Our range, same type of thing. We start bottom up, and our first value, well, I guess first of all, it's y now that we're dealing with. And y is between, well, the smallest y value is -1, and it can be -1 because it's a closed circle, and it goes all the way up to 3, and it's including 3. So that's our set builder notation. In interval notation, square bracket, -1, comma, 3, because we went from -1 up to +3. Well, let's move on to letter B. Again, our x, our domain. First, we got to set it up. So x, the lowest one we have is -4, and then all the way to the right. So first of all, it's not less than or equal to, or greater than or equal to, it's just less than or greater than, depending on which one it is. And we're saying that all our x values are greater than that -4. And that's it. It's just greater. It goes on for forever. In interval notation, we start at -4. It's a parenthesis because it's an open circle. And as we keep going to the right, we're going to the right for forever. So if we're going for forever, we got infinity here. Range, same idea, but now we're talking about y's. So set builder notation, we got y such that our lowest y value is 1, and it goes all the way up for forever because, again, on the right side, this arrow is going up, and it's not going to stop. So that just means that y is greater than or equal to 1 because that 1, this point, is shaded in. And then an interval notation starts at 1, including 1, and it goes up for forever. Again, forever is infinity. Right. Go through these a little bit quicker so that this video is not 4.5 hours long. Domain and range. Domain, we go all the way to the left, all the way to the right. All real numbers, or from -infinity to +infinity. Our range, well, we got a lowest y value, and we got no highest y value because it just keeps going up. So we got y such that, well, what are our y values? Well, they're -4 and bigger, so greater than or equal to -4. Close the squiggly brackets. Our interval notation is -4, square bracket, because it is shaded in. If it wasn't, we'd see an open circle there. And it goes up for forever, so it's infinity. Letter D, last one here. We don't have numbers on it, which kind of stinks. So domain, our x value from here to here, that's 1, 2, 3, 4, 5, 6. So -7. Oops, that's not what we want. It only erases when I don't want it to erase. So squiggly bracket, x such that. Now x is sandwiched in between -7 and 5. -7 included, x less than 5 not included because it's an open circle at 5. If we were to do interval notation, starts at -7, including -7, it goes to 5, not including 5. And our range, our lowest y value is -3, and our highest y value is 1. So -3 to 1. It can be -3 because we got a shaded in circle, but it can't be 1 because we have an open circle there. And interval notation would be -3 bracket to 1 parenthesis. That's our interval notation and set builder notation. Really going to focus on the interval notation. All right, function notation, f of x. All that's saying is that the function is named f, and x is the variable we're going to use. That's it. Nothing any crazier than that. So this is saying, again, f of x. So x is 2. So we go 2 on our x, go up to where it meets our graph, our function, and over to find our coordinate. So 4. Same thing with 1, comes up here to 7. So those aren't too bad. Where it gets a little bit more involved is where we have these. We have f of x something equals 3. So we need to find the x, and they give us the y now. So what x value gives us a y of 3? So we start at y of 3, we go over, up, there's our point, and that gives us an x of 3. Likewise, f of something gives us a y value of 7. So we hit 7, we go across. Now there's actually 2 points that work. There's 2 numbers that if we take f of them, they become 7. So we got 1 and 5. And that's fine. We can have more than one answer there. All right, domain. Again, it's going all the way to the left, going all the way to the right. So it's all real numbers, or negative infinity to infinity. Our range, well, we got a lowest y value at 3, including 3 because it's a shaded in circle. And then we go up for forever to positive infinity. And then lastly, the last 2 things, the vertex, hopefully remember from last year, is there. So that's 3, 3. And our axis of symmetry is always going to be the line that goes directly through the vertex. And it's going to be an x equals line, because that's what vertical lines are. Well, what does x equal? Well, if you look at the ordered pair, x equals 3. And that's our axis of symmetry. That's all we need to do there. Keep on moving. Got a couple more examples. Go through them a little bit quicker. Now, the next thing we should probably do is see how to graph these things. So if we, where's my calculator? We look at the calculator, we hit y equals, then we use this button here, the button next to the alpha button for x squared, and then minus 3. So y equals gets us here, we type in our equation, we hit graph, and now this doesn't look right. We have to reset the window. So we go to zoom, and then number 6, Z standard, puts it back to what we're used to. And now we can see our graph. But that's all great, but we need points to connect to actually make a good graph. So we hit second graph, and now we have a bunch of points. So we have what we need, we just got to plot them. So we got 0, -3, 1, -2, and -1, -2. So 0, -3, here and here. Again, we need at least 3 points. And then that's our graph. If we wanted to use Desmos, which doesn't look like I have up anywhere here, I will get that up. I don't know where it went. I apologize. Here, we just type in f of x equals x, and the little caret key, shift, and then 6 squared, and then minus 3. And we can click on those points, the x-intercepts. They're not whole numbers, so it kind of stinks. We get the vertex, that's a whole number. But if we want more values, we hit the gear and then the table. And now we have the table of values, so we can plot those points too. So that's how we graph using the calculator or Desmos. So our domain, again, it's a parabola. So domain's always going to be negative infinity to positive infinity. Our range, we have a lowest y value at -3. And all the rest of them go up on forever, so to infinity. So parenthesis on infinity, square bracket on -3, because there is a point at -3. -3 can be our answer. Our vertex is also right there, so -3, 0. That means our axis symmetry is x equals, well, what does x equal? -3. Then f of 2, so we're saying x is 2. What's the y that goes with it? Well, when x is 2, and it's a little bit tougher there. So maybe we go back to Desmos, or we could use a calculator, but we can clearly see that when x is 2, y is 1. So you just click on it and you got your point. It's kind of nice. So it was 1. Now this is saying if f of something, or we need to find an x when y is -3. Well, this is just the reverse of, oops, we wrote our vertex wrong. By we, I mean me. I wrote it backwards. 0, -3. So that makes my axis of symmetry wrong. X equals 0. So when y is -3, when we see that right here, x is 0. Right, we got a couple more here. Nothing too outrageous. So we can use the graph or calculator or Desmos to graph this. We're going to learn that it's a little bit easier to graph than just, than just that. We'll be using some transformations, but we don't need to worry about that yet. So this function looks like this. Remember, our absolute value is a v. Our domain, never erases when I want it to, is from -infinity to +infinity. It goes all the way left, it goes all the way right. The range, well, it starts all the way on the bottom. So all the way on the bottom is -infinity. Because we keep going down negative, that's where we get. So that's always a parenthesis. And it goes up to y equals -5. And that's included because there's a point there. Our vertex, our point right here, at -2, -5. Axis of symmetry is x equals -2. And again, one way that we can get what f of x is plug it into the equation, but we don't need to. X equals 2, we go down to our y, it's -9. And f of something's -3. Well, we go -3 on our y, there's nothing there. There is no value that will give us a y value of -3. So that can't happen. Right. Another thing back to our calculator, so -x squared plus 15, or Desmos for that matter. Negative. We can't see the whole thing, so that's no good. So we can just pretend like it's a phone, move it around, and now we got it. We look at the wrench, and these are the numbers that we're going to put there. We got -18.87 to 18, we'll just say -18 to 18, and -4 to 18. That's our window. That shows us what we need to see. Same thing on the calculator. So it was -x squared plus 15. Didn't mean to do that. Try this again. -x squared plus 15. Again, we graph, we can't see the top of it. So here we got to change our window. Well, we need to see up. So farther up, well, up and down is y, and up would be our max. So we'll change it to 20. Now when we graph, oh, we can see everything, we're okay. So x min could be negative 18. X max 18. Or no, we didn't have that. We had much smaller than that. That'll work. And we can just make them both negative 18, 18. Our vertex, if we look at either Desmos or the calculator, 0, 15. So our axis of symmetry is going to be x equals and x equals 0. So kind of looks like that. All right, now we got a little bit more, but now we're talking about some word problems here. Let's go this way. What is the domain and range of the situation? So we have something we're selling, and we're getting some profit. I don't know what we're selling, but hopefully it's good. So how much, so our domain is our X value, in this case, selling price. Our lowest selling price that we can sell it for is 10. It doesn't go any lower than that. We're not going to charge less than 10. And we can charge 10, so square bracket. And then it goes all the way over to 60. That'll be the most that we spend. So 10 to 60, anywhere in there, that's our domain. Our range, the money we're making, well, the lowest Y value that we can see here is 0. Of course, unfortunately, we can make $0. And then we go up to about this point. I think in class we said about 62.50, and there is a point there. So that's the most money we can make. So P of 40 is asking us, if we charge $40 for this thing, how much are we going to profit? Well, just like we did before, that's saying X. So go up, 40 equals X. Go over to find our Y. So that would be $6,000. So hopefully we'll sell it at that price. What are the x-intercepts? Well, we got 10, 0, and 60, 0. What do they represent? Well, that's $10 selling price or $60 selling price, and the Y are both the same, the profit. So that's our break-even point, because we have no profit there, but we're not losing anything either. So these are our break-even points. When is profit increasing? Well, profits are Y, so when is it increasing? Well, it's going up here. So from 10 to whatever this might be. I think we said that was 35. That's our increasing interval. And decreasing as we go left to right, it's where we're going down. And we're going down the second half there where I highlighted in green. So that starts at 35 and it goes to 60. So we use our X values to say when our Y is going up and down. Now, very similar, except now we're talking about profit negative and positive. So this is all positive. It'd be negative if we charge between $0 and $10, because that's here, so our graph would be going down, or if it's anything over $60. So 60 to infinity, because we can charge as much as we want, but we're not going to make any money. But again, this is going to be going down. When is it positive? Well, from 0 to 60, because it's all above the x-axis. All right. We're going to skip number 5. I don't think we need to do something quite like that. Let's look at the U tries here. So something that I didn't focus on a whole lot in class, and I want to talk about it here, is when we are finding our x-intercepts, y equals 0. When we're finding our y-intercepts, x equals 0. So whatever intercept we're finding, we plug in 0 for the other variable. So for our x-intercept here, we're going to plug in 0 for y. So we got 0 equals the absolute value of x equals -3. So we add 3 to both sides. The absolute value of something is 3. That means it's 3 away from 0. So it's either 3 or it's -3, because the absolute value of -3 is also +3. And our y value is 0 because that's what made it our x-intercepts. Our y-intercept is a little bit easier. It's where we plug in 0 for x, and then we just simplify the rest of it. So we got 0 for x and -3 for y. That is our y-intercept. Letter B, we'll do the same thing. Our x-intercepts, it's when y equals 0. So 0 equals 4 minus x squared. I think the easiest thing to do is add x squared to both sides. We got x squared equals 4. To get rid of that squared, we square root it. So x equals plus or minus 2. Because again, -2 squared is also 4, as well as 2 squared. So we got 2, 0, and -2, 0. With our y-intercept, x equals 0, so we just plug it in. So that's 4 minus 0, or just 4. So our ordered pair would be 0, 4, because we made the x 0 anyways. All right. And really the last new thing that we're going to talk about, well, a couple things, is our positive and negative intervals. We kind of talked about them already, but we're going to get into them a little bit more. So reasons of the function that are positive, oops, nope, that's not what we're asking, that are above the x-axis, the inputs are producing positive y values. It's just above the x-axis up here. Negative intervals are where the function are below the x-axis. The inputs are producing negative y values. So again, we're just looking to see where it starts and stops being above the x-axis or below. And these are all going to be parentheses when we write these. So in this first graph, we're positive here and positive here. Those are the only two places that we're above the x-axis. Well, this graph keeps going left. And far left, that means we're actually starting at negative infinity because it's all the way to the left. Then we're coming over and it stops when it gets to the x-axis at -3. So for our positive negative intervals, I didn't do that. We are only going to use the x-intercept numbers. So -infinity to -3, and then it picks up positive again, or starting at 3, and it goes up to the right for forever, so infinity. Notice negative infinity is first, then -3. We go left to right. Negative infinity is the smallest thing you could think of, then -3. Then 3, and then infinity is the biggest number you can think of. So we have to go in chronological order. And then for our negative interval, that's just the part in between. And that's not too bad because it just starts at -3 and it goes to 3. Those are always going to be parentheses. So same thing on this next one, except it's upside down. So it's negative in these two sections here. So that's from negative infinity to -2. Because even if we're way, way, way down here, we're traveling along to the right, we're still negative, we're negative, we're negative, we're negative, we're negative, oh, now we're positive. So we stopped at the -2. Where do we pick up being negative again? 2. And then it just keeps going to the right for forever. Again, we're talking about x values. So we're looking at all these x values. We're not looking at any y values. And then, of course, in between, it's positive. So that's from -2 to 2. That one's not so bad. Let's look at a couple more of these. Do some different colors here. Oops, that's not what I want. So we're positive from here to here, and then back here again. So we got 2 parts. That's okay. So we're positive from -4 to 2. That's what's going on here. And then it picks up again at 6, but it goes on for forever, so that's infinity. Infinity is basically our way of saying forever. And then let's try. It doesn't even matter. I don't know why I'm making a big deal out of it. Here and here. So this first one, well, it starts all the way on the left where we can't see it. It's negative infinity. It goes up to -4. And then it picks back up at 2. And it's negative, 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 comes back up, and it stops at 6 where the orange picks up. Well, we got Bears colors there. And that's positive, negative intervals. Increasing intervals, and this will be the last thing we do, are where we're going down or up as we go left to right. So we're decreasing, then here we flip it, and now we're increasing, increasing, increasing. Then here we flip it, and we're decreasing. So it's where we're going up or down, left to right. So again, we'll use our highlighters. So it's increasing. Well, this is a lot easier. There's only a couple different things. It's increasing as we go left to right. Well, that's where we're going up, and that's it. So that's from negative infinity, because it's all the way to the left, up until this point, and the x value of that point, so 0, not the y. So what does it do after it increases? Well, of course, it's going to decrease. Whoop. So that starts at 0, that point there, and it goes to the right for forever, so positive infinity. Now the next one's kind of a trick. Not a trick per se, but as we go left to right, we're decreasing, we're decreasing, we're decreasing. That's it. We're off the coordinate plane now. That's all we got. So increasing, there isn't any. Decreasing, it's the whole thing. It's all the way to the left to all the way to the right. So it's our all real numbers, or what we use, negative infinity to infinity. And now this last one, a little bit different. So we are decreasing, 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 decreasing. And then from 1 to 3, this little flat part, we're not increasing or decreasing. So it's nothing. But then at 3 again, we start picking it up. So increasing is from 3, and it goes to the right for forever. And that purple starts at -4, and it goes to that point at 1. And that's how we do increase and decrease intervals.